In this video, you're going to learn how to factor quadratic trinomials where a, the leading coefficient, is not 1. So two methods are going to be used in order to factor expressions that look like this: product and sum, as well as grouping. So if you don't feel comfortable with either of those two methods, please go watch a video on how to do those first and then come back here. All right. So product and sum. Our product is A times C and our sum is B. If you forgot what that means, I'll explain it in a minute. We're going to start with the standard form of a quadratic: ax squared plus bx plus c. This is going to help us identify what the a, b, and c are in our expression. All right. So the a is the coefficient of x squared. So that's 3. The b is -2 and the c is our constant -5. So our product is a times c. So in our case, 3 times -5. So our product is -15. Our sum is b. So b is the coefficient of x in a quadratic. So when we look at our expression, the coefficient of x is -2. So our sum is -2. So now what this means is that I'm looking for two numbers that are going to multiply to give me -15. And those same two numbers are going to add to give me -2. So now it's just about figuring out what those numbers are. So think about it before I say it. All right, so if you got -5 and +3, you are correct. You can't switch the signs around, right? Because even though either way you put the sign, we'll still get -15 as a product, it wouldn't work for the sum. So -5 plus 3 is -2. If I switch those signs, I would get +2. So now, once we've determined what those two numbers are, instead of just setting up our two binomials like we do when a is 1, there's an added step to this, all right? So I found my numbers to be -5 and 3. What I'm going to do now is I'm going to take this middle term and I'm going to split it and rewrite it so that it's the sum of -5p plus 3p, right? I'm allowed to do that because the value of this expression is still -2p, so I didn't change anything. I'm going to bring down my first and last term. So 3p squared minus 5p plus 3p minus 5 is the same as the black expression that I started with. I'm just rewriting it differently. Why? Because now what I can do is I can factor by grouping. All right. So once again, if you have trouble factoring by grouping or haven't done it yet, please go watch that video first. So to factor by grouping, I'm looking for the GCF of the first two terms. So 3 and 5 don't have a numerical GCF besides 1, but both of these terms have a p. So I'm going to factor out a p, and then I'm going to divide both of these terms by the GCF to find out what goes inside of my parentheses. So 3p squared divided by p is 3p, and -5p divided by p is -5. All right, second set of expressions. 3p minus 5. The GCF between these two terms is just a 1, right? They don't both have a variable, so I can't take out a variable. And the numbers 3 and 5 are both prime. The only thing they have in common is a 1. So when I factor out a 1 inside my parentheses, I get 3p minus 5. Now, if you remember from the grouping video, this is a sign that we're on the right track, right? We want to have the same thing inside of these parentheses. So when we do, we can now factor out that 3p minus 5, and we're left with p plus 1 in the other parentheses. And so here is my factored version of my initial expression. All right, here's my second example. So I have a quadratic, it's a trinomial, and a, the leading coefficient, is not 1. So I know that I'm going to use product and sum and then the grouping method. So let's start with product and sum. My product, as a reminder, is a times c. So in this case, a times c is -18. That means that I'm looking for two numbers that will multiply to give me -18. My sum is b in ax squared plus bx plus c. Here's my b. B is the coefficient of n. So 3 is my sum. So I'm looking for two numbers that are going to add up to 3. And those same two numbers have to multiply to -18. So think about it for a minute. Pause, see if you get it before I do. The two numbers are going to be -3 and +6. All right, those two numbers will satisfy both of these equations. So now let's do just like before. We're going to take these two values and we're going to use that information to split this middle term. So instead of writing a +3n, I'm going to rewrite this as -3n plus 6n, right? So that's where these two numbers came into hand. I use them as the new coefficients of that variable. I'm allowed to do that because negative 3n plus 6n is 3n. So I haven't changed the value of this expression. All right, give myself some more room. And now we're going to bring down the first and last terms and continue. So now that I've used product and sum, I'm going to the grouping method. So the grouping method says we're going to take the first two terms, we're going to take the last two terms, and we're going to factor them in pairs by GCF. So the greatest common factor of 2n squared and minus 3n is n. All right, and when I factor that n out, 2n squared divided by n is 2n, and negative 3n divided by n is negative 3. I'm done with the first pair. The second pair, the GCF of 6n and minus 9 is going to be 3. So I can factor 3 out of here. 6n divided by 3 is 2n, and negative 9 divided by 3 is negative 3. So now I see that I have the same expression in both of these parentheses, which was my goal. So I'm going to factor out that 2n minus 3, and I'm left with n plus 3. And I am done. Okay, as always, I'm leaving you guys with a practice problem to try on your own. When you think you have the answer, check the video description because the answer is in there, so you'll know if you got it right or not. Good luck.